Hi everyone, fluid mechanics. In this example, we have an interesting problem in calculation of severe flow rate in a concrete pipe. So, as you can see here, the pipe is partially filled with water, and the specification of the section in terms of geometric are provided. So, radius is provided, R is 18 inches, H height of water, which is severe, is 9 inches. Manning's coefficient is 0.025. We want to calculate the discharge in terms of cubic feet per seconds. So in order to do so, we can consider the data or information of the problem like radius, height of sphere, the longitudinal slope, which is provided to be 1%. Manning's coefficient is provided n, and we want to calculate the flow rates in severe system. So based of Manning's equation, Q is equal to 1.486 over Manning's coefficient times area times hydraulic radius to the power of 2/3 times longitudinal slope to the power of half. So we need to calculate the area of sphere and also hydraulic radius first. To do so, we can use any geometric element of channel sections guideline, and it just gives us like what would be the area and what the hydraulic radius is. So area is come from this equation, and hydraulic radius is calculated based off the equation below. As soon as we know that, we can just consider if the total degree is theta. Due to symmetry, we can calculate half of that. That's theta over 2. If this is the radius, and then height of water is h, this is like a radius, that's r minus h. Then we can easily calculate cosine of theta over 2. That's r minus h. That's r minus h over r. And we have like radius is 18, height of water is 9, and it just gives us cosine of theta over 2 is 0.5. That gives us a half of theta is equal to 60 degrees. Then theta is 120. Don't forget to convert the theta to in terms of radians. So multiply that by pi over 180, and it just gives us a theta is equal to 2.09 in terms of radian. As soon as we have theta, we can just jump to the area and calculate area, and that's 1 over 8 times theta, which replace from here minus sine of 120 degrees. Then don't forget to, if radius is 18 inches, so diameter is 36, don't forget to convert that to feet because we want to have our calculation. Finally, Q is based of cubic feet per second. So 36 convert to feet is 3 feet squared, and it just gives us area is 1.38 feet squared. So far we have calculated theta, we have calculated the area, and we have to then calculate the hydraulic radius. Hydraulic radius is a quarter of bracket 1 minus sine of 120 over theta, which is 2.09, close bracket, times the d, which is diameter, which is 3 feet. So it just gives us a numeric value of r, or hydraulic radius, is equal to 0.44 feet. Then if we just have all the component in Manning's equation, we calculate so far calculate the area, hydraulic radius. So A is 1.38 feet cube, R is 0.44 feet. Then by having them in the main equation, and the rest are provided because the Manning's coefficients is provided in problem statement. A longitudinal slope is 1%, so that's here to the power of 0.5 in Manning's equation. And if you do so, it just gives you a discharge of 4.75 cubic feet per second. And with the flow rate in our channel with this specification is 4.75 cubic feet per second. Thank you. We'll solve more problem in terms of open channels, hydraulic closed channel, hydraulic in fluid mechanics. Thank you. Please share your thought and consideration with me.